Okay, welcome back for that second part of section Q. Here is an example, and what we're given is this general conic. You notice we have an xy term, and we're supposed to write it in this format. Now, what this basically means is we can easily see from this at least what the type of translation is. And then in the process of going from here to here, I'll be able to find out what the rotation is. So my answer many times can be that this conic is really just this conic rotated. And of course we can see what happens here. Then depending on what A and B and F are, we could identify the conic and figure out kind of where it's placed and all of its little characteristics. One thing I will not do in this example is show every little algebraic step. I'll let you work through some of those. I'll basically try to kind of give the results of what's happening here. So here we go. First and foremost is you might notice that this varies from the general form a little bit. I like this to be an even number. So one thing I'll do right off the bat is to change it by multiplying everything by 2. And I'll also just set it equal to the constant so we get it to the other side. We're always allowed to do that. It's the same equation, but that way I can identify parts of this. So then, if we look at the steps from the other day, or the other video, is we want to write it in that quadratic form. So basically, I know that my x, you could say let, equal the xy. That's not the big deal. That's always just my variable matrix. A is basically going to be 2 and 2 on that main diagonal, because that's your A and your C, and both of these have to be B. Well, if that's 2B, both of these are going to be -1. Okay? And then your V is going to be the -4, 2. Okay, now once we have that, and I'm not going to go through the whole process, but the normalized vectors are normalized vectors, eigenvectors, would be 1 over radical 2, 1, 1, and then -1 over radical 2, 1, 1. Now remember, that is the process of taking A and figuring out its eigenvalues. Once you have the eigenvalues, you have your eigenvectors. Keep in mind the eigenvectors are really kind of a parameter. There would be a scalar with it, but we can take it when t is 1. So we might get 1, 1 and 1, or -1, 1. But then we're going to go ahead and need to normalize it, which means make it a length of 1. So those are the two values. And so what that means is P is going to be the vector 1 over radical 2 times 1, 1, -1, 1. Get rid of that. So that's really kind of the first big thing you have to do. And it's a lot of work to get there. We change it to our quadratic form, and we find that P, which is basically our orthogonal vector based on the eigenvectors of A. Then what we can see is that from this, we can get the rotation. We notice that as our rotational matrix. So the cosine of theta is 1 over radical 2. And the sine of theta is -1 over radical 2. So what that means is theta is going to be -pi/4. And that's a big part of this whole work. So we know that this thing is basically going to be rotated at -pi/4 once we have it in a standard form. Now, the next big step is we're going to let that x be p x prime. We let x be p x prime. What happens then from this form right here? Nope, we didn't really write it in that form, did we? Okay, but if we do write it in that form, let's see what it looks like here. We have Px inverse transpose P, and then Px prime. I should say prime, not inverse. Sorry about that. Plus our V transpose, which is negative 4, 2, Px prime equals 6. Again, all we're doing here is this would have been our normal x value, and we put it in that quadratic form. Now, here's where a lot of work takes place. If we go ahead and plug in everything we know about P, A, this thing should be A. I think I said it but didn't write it. So we plug all this stuff in, we're going to end up with 3 times x prime minus 1 over radical 2 squared plus y prime minus 1 over radical 2 squared, get this all right, equals 8. Okay, which is basically 3x squared plus y squared equals 8. So it's that equation translated basically the 1 over radical 2 and negative, 1 over radical 2 for both, isn't it? So let's put this together and see what that all means. Okay, let's work from the back. We know what this is. This is an ellipse. If we divide everything by 8, we're going to be able to write x squared over a number, y squared over 8 equals 1. So we can put that in an even nicer form and we immediately know what's going on, but it really looks something like this. So this has a center at 0, 0, but now we're translating it basically radical 2 over 2 and radical 2 over 2. Once we do that, we are then going to rotate it a negative pi over 4. So it goes from being an ellipse, kind of at the center, or at the origin, to an ellipse that now has its center over radical 2 over 2 left and up and to the right. And then finally, we rotate it a negative pi over 4. Okay, take this and just rotate it. So that's something we could get into if we were asked to sketch it, but that's basically how we go about starting with a general conic and putting it in a more standard form. And it's using a lot of mathematics that we've had in the past. Now I've left out, as I said, a lot of the details, but there are some great examples in the text that I'm sure you'll be studying. But let's come up with some results of what we're really can find out about this. And these results kind of come through this process, also an investigation and even some problems in a problem set. First of all, on page 228, number 3, there is a whole table that I'm not expecting you to complete, but if you were, we would come up with a few results. One is that A plus C is the same as the sum of your eigenvalues. It's kind of nice to know. Also, if the product of your eigenvalues is greater than 0, we're basically looking at an ellipse. If the product of the eigenvalues is less than 0, then we know it's hyperbola. Again, if you went through this and did all of the problems required to fill out that table, these are some results that you would probably find. Also, there is an investigation, the very last investigation of the book, really, And here are some neat things. There's something known as the discriminant. It's not your standard discriminant. It's a little bit variation of what we had with quadratics, but it's just b squared minus ac. And if the b squared minus ac is greater than less than 0, basically we know that this thing is going to be an ellipse or a circle. Now there are some other options. It could just be a point, all right, and it could maybe have no graph at all, where it just doesn't fit any of these conics. If b squared minus ac is greater than 0, then we're going to get the hyperbola. Now, it could be a hyperbola, it could be a line pair, because sometimes the hyperbola gets to be the degenerate case, where it's just going to be the kind of the two intersecting lines. Just like the circle or ellipse could have the degenerate case of just being a point. And then finally, b squared minus ac equals 0, you can probably guess that we're going to have a parabola. Now, it could just be a line, could be parallel lines, or could be nothing. So there are some other issues here, but that's just understanding what it means to have these degenerate conics. So, as a quick recap, if it can be done, we have a general conic. We like this to be a even number, so we can identify the b very easily, but we're going to write it using these substitutions in what we call quadratic form. It's then all about some linear algebra, finding the eigenvalues and eigenvectors, because if I let P have the columns of those eigenvectors, we can hopefully identify the rotation. As I said, if this doesn't come out to be a recognizable angle, we can just write it as an arctangent of whatever number that is. And we could get a decimal approximation if you want to get a better feel. We then, for the big part of the algebra, is we let x be P x image, or x prime, we go ahead and write it in that quadratic form and just rearrange, collect terms, a lot of algebra. We can hopefully get it in what we might call the standard form. At that point, we can identify what type it is. We can then know how it's translated, and then put it back with the rotation. We understand more about this conic. Now, even before you go to this extent, you can identify it just by taking the discriminant. This one, for example, we know was an ellipse. So it should fall into this category. And if I would take b squared minus ac, b squared minus a times c, what do we get? Well, the b was 1, the a and c were 2. So b squared, so it's 1 squared, minus that difference. It's going to be less than 0, should be an ellipse, and it was. That's it. Later this week, I'll come back on with an announcement on what comes next. Eventually, there will be a test over all of this geometry that you'll have several days to work on and submit, and I'll grade it. And then we'll hopefully be able to have a few weeks of just filling in some gaps on some of our other topics. It's been a long video, couple videos, so good luck. Keep working on the one handout you have already and get that to me whenever it's completed. Thank you.